Trigonometry is the study of the relationship between side lengths and angles of triangles. So in the past, we have learned that a triangle has 3 sides and 3 angles. And when we have a triangle that has a little box, such as this one on angle B, we call those right triangles. And we have been able to use the Pythagorean theorem to find a missing side of a triangle when we have 2 sides. And we know how to do this with a right triangle only. So now what happens when we have an angle and 1 side length, but we don't know the rest of the measurements? So in that case, we use trigonometry. So we have Mr. Triangle over here at the bottom, and we know that, let's say we have a distance AB on the ground that can be measured. And let's say that there's a height that we don't know, but we have this angle. And you would like to know, well, what is the distance from the foot of the triangle all the way to the top? Well, for that, we're going to need to know the reference angle. And since Mr. Triangle is standing here at side A, at angle A, at angle A, we're going to call side AB the adjacent side. The adjacent side is always one of the sides of the reference angle. The side that's across from the 90-degree angle, that is called the hypotenuse. And then the side that's all the way across from the reference angle is called the opposite side. Okay, so remember that the adjacent side and the opposite side is all relative to our reference angle, our position that we're interested in. The hypotenuse is recognizable because it's always the longest side of a right triangle, and it's always across from the 90-degree angle. Okay, so let's take a look over here. What if we have Mr. Triangle here at the top at point C? Well, we would call C our reference angle. Which one would be the hypotenuse? Well, the hypotenuse is still going to be the one directly across from the 90-degree angle. Since Mr. Triangle is standing at point C, side BC is going to be our adjacent side. Let's see if I can rotate this so that we can see it better. So that's my adjacent side. And the side directly across from the reference angle is our opposite side. Okay, so now let's try to figure out the relationship between our sides and the angle. So the first trigonometric function that we're going to learn is called the sine function. The sine function, the shortcut is spelled sin. Don't call it sin. It's sine. So the sine of angle C, the function with respect to angle C, is equal to the ratio of the opposite side to the hypotenuse. The second trigonometric function that you're going to learn is called cosine. and the shortcut is COS. So the cosine of angle C is equal to the adjacent side over the hypotenuse. So notice that for both sine and cosine, in the denominator of the ratio, we use the hypotenuse. But when we're dealing with the sine function, the ratio is opposite over hypotenuse. When we're dealing with cosine function, it's adjacent over hypotenuse. And the third primary trigonometric function is the tangent of angle C. The shortcut is tan of angle C, and that is equal to the opposite side to the adjacent side. So notice with the tangent function, we are going to set up the ratio between the two sides of the right triangle that form that 90-degree angle. Okay, so let's look at an example. We have a triangle ABC with the following measurements. Side AB is 12 feet, side BC is 16 feet, side AC is 20 feet. Which one is the hypotenuse? Well, the hypotenuse is the side that measures 20 feet. It's the longest side, and it's the one across the 90-degree angle. Opposite from the reference angle, here's my reference angle at A. I'm going to go all the way across, and opposite side is 16 feet. And adjacent is the side that's part of my reference angle, that side that forms the reference angle. So my adjacent side is 12 feet. Okay, what if we changed the reference angle? So here's Mr. Triangle again, and we decide that the reference angle is going to be at C. What changes? Well, the 12 feet is no longer the adjacent side, so we're going to move that out of the way, and we're going to move our opposite side so that it becomes the 12 feet. And the adjacent side would be our 16 feet. And you might wonder, does it matter? Well, it does matter because our trigonometric functions are ratios of these three sides. So if we're looking at sines, the sine of angle C, it's going to be opposite. So that's going to be 12 feet over the hypotenuse, which is 20 feet. So we would type 12 over 20. The cosine would be the side that's adjacent. So that would be 16 over 20. And then the tangent is always the sides that form the right angle, and it's opposite over adjacent, so it'll be 12 over 16. Okay.